So today we're gonna do something a little bit different than the previous sessions. And we will be starting with a couple of problems from the AMC8. Do the two of you guys know what that is?
Yeah, I think we did it last class.
Yep, that is the American Math Competition. And we selected a couple basic problems from it. And here it is. Can you guys see it? Well, let's just jump right in. So can you guys see problem 17?
Yeah.
Yeah, so the operation, whatever you call this, is defined for all non-zero numbers by a, we'll just call this x for the sake of reading the problem. The operation x is defined for all non-zero numbers by axb equals a squared over b. Determine this. So do you guys want to give a go at this problem, or Kemi, you have any ideas for how to do this?
I don't know. I've actually never seen this kind of problem.
Yeah, well, this problem is really just by nature an arithmetic operation computation. So it follows the same rules as, for example, a multiplication problem like 1 times 2 or 4 times 8. And we just follow the order of operations. So we'll start with this parentheses right here. So we want to calculate 1 x cubed. Lloyd, can you calculate this for me?
Is x times?
Lloyd, sorry, Kemi, you're like a bit lag. Lloyd, do you want to try it? Well, so basically, as you can see, the operation is defined right here. So we just really just plug 1 and 2 for A and B. So, Lloyd, were you saying something? All right, as I was saying, you just plug the numbers into A and B, and you would get 1 squared over B, which is in this case 2, right? And so now it's pretty obvious what the answer is, right? It's 1/2. Does everyone agree?
Okay.
And so now we can basically replace all of this with 1/2 as we just calculated.
What does this x mean? Does it mean times?
Oh, so this here is specially defined operations. It's not add, it's not subtraction, it's not multiplication, and it's not division. It's defined right here. And you can see the operation involves 2 numbers. And when you put A and B next to the operation, you get this. Does that make sense? It's like a special operation.
Okay.
Yeah. And as I was saying, like you just plug 1 here for A and 2 for B. And you use the operation definition here. And you would get 1 squared over 2, which is 1/2. Does that make sense?
Pretty much.
All right. Well, now we just do the same thing again, except the numbers are now 1/2 and 3. Kimmy, do you want to try it?
Uh, 1/2 and 3. So we change a into 1/2.
Yep.
B into 3. That means 1/2 to the 1/2 squared
Yep.
3.
Very good. And do you want to keep on simplifying it? What would it simplify to?
2.
Are you sure?
I don't know how to simplify fractions of fractions.
Oh, okay. Well, here's a quick crash course. So basically, right here, up here, it's 1/4, right? Because 1/2 squared is 1/4.
True.
Uh-huh. And on the bottom, it's 3. And what this really means is the top, you take the top 1/4, and dividing by 3 is what? It's really just multiplying by 1/3, right?
Okay.
So what's the answer?
34. 3 over
Uh,
4.
Not quite. So when you have two fractions you're multiplying together, you basically just multiply the numerators together and the denominators together. So top with top and bottom with top, bottom.
Okay.
So here, I'll go through this with you. So oh my God, that was not good. So what's 1 times 1? It's 1, right?
Yeah.
And 3
So 1
times 4?
over 12.
Yep, very good.
That means 2 over 6.
Not quite. 2 over 6 is a different fraction. And
Oh, okay.
yeah, yeah, because like 2 over 6, it's like
Kind of more
1/3.
bigger.
It's fine. We'll get more practice as we finish this part because we still have to calculate two more. So we just got 1/12 for all of this. I'm going to erase this real quick so that we have more space to write. All right. So as we just figured out, this whole thing is 1/12.
Is this Jamboard?
Yep, this is Google Jamboard. And we want to use the same logic we just used to calculate this to calculate this. So Lloyd, do you want to try this? We want to start with this inner parentheses first. Hi, Kathy. Kathy, we're solving a problem from the AMC8. And basically the problem is we have a special operation and we want to calculate this. So Lloyd, go ahead.
Is there a negative 1/4?
I'm sorry?
Is the a 1/4?
Oh, we'll find out soon when we finish the other calculation. Lloyd, go ahead. So Lloyd, we want to start with the 2 cross 3 first. So Lloyd, do you know how to do it or do you need some help?
2/3.
You mean as in the answer?
Yeah.
Well, you're close. You're very close.
Oh, 2 square third.
Yep. So, well, you gotta remember we have a squared here. So any number you put into the a has to be squared. So for example, when you put in the 2, it has to be the square of 2, which is 2 times 2, which is 4. So it's 4/3, but you're very close. Let's try this again. Here we got 1 cross 4/3.
4/3 square of 1.
Be careful which one you're squaring.
Oh, 1 squared 4/3.
Yep. So that's just 1 over 4/3.
1 squared is still 1, right?
1 squared is 1. Yep.
1 cubed is also 1, right?
1 to the any power is 1. So Lloyd, Kathy, do you want to make the final simplification for this fraction?
Well, 1 to the power of 0, 1 times 0 is not 1.
Well, this is going on a bit of a tangent here, but sure, I'll explain it real quick. So basically, 1 to the any power is 1 because if you think about it, if you multiply 1 by 1, no matter how many times, it's always 1. So 1 to the any power is 1, including 0.
What? 0 1's added together is 1?
Well, that's going to take a bit more advanced math to explain, but basically, if you think about it, 1 over 1 is 1 to the 1 minus 1, which is 1 to the 0, right?
Okay.
And 1 over 1 is 1, so that must mean that 1 to the 0 is equal to 1. Does that make sense? I know the 0 on the top of the 1 makes it look confusing, but trust me, 1 to any power is equal to 1. And now let's go back to this. Kathy, do you want to make this simplification?
Just asking, this kind of looks like Baymax. This right here.
All right, I'm going to go ahead and do this. So basically, if you haven't learned about fractions yet, when you have a fraction on the bottom, you just flip it around and you get 3/4.
Okay.
So the two numbers we have are 1/12 minus 3/4. And if we just calculate this, we get the answer. Does anyone know how to calculate this?
101.
Not quite. Lloyd, Kathy, do you guys have an idea? Go ahead, Kathy.
I hate math. I love math, but my worst enemy is fractions.
All right, then I'll just go through another quick crash course real quick.
I don't know how to add fractions. I do not know how to minus fractions. I do not know how to plus fractions. I do not know how to divide fractions.
That's fine. That's fine. Hey, Joyce. So we're on the final step of this AMC problem right now, and we're trying to calculate 1/12 minus 3/4. If you want to do that for us, it'd be really great.
What is AMC?
Joyce, can you hear us?
Yes.
Do you want to go ahead and finish the problem?
I don't know which part we're at.
Oh.
We're at 12 minus.
So we're
minus
doing this calculation right here. So if you know how to work fractions, go ahead.
I do not understand.
Okay, well, here's, ladies and gentlemen, here is how you work fractions.
2/8. I think the answer is 2/8.
The first step to subtraction or addition of fractions is to make the denominators, which is the bottom number, the same. And the way you do that is you multiply the top and the bottom by the same number. So what number would you multiply 4 by to get 12?
3.
Very good. So that means we multiply the top and bottom by 3. The 3 on the top becomes 9 because 3 times 3 is 9. And the 4 on the bottom becomes 12, obviously.
9 12.
Yep.
Oh, that's
And
easy. 8 12.
you're very close, but
I'm
be
bad.
careful with the sign. Is it 8 12s or...
It's 12 eighths.
Well, it's actually negative 8 12 because 9 is actually greater than 1, but you're very close. And finally, we just make the final step of simplification. You
Wait,
divide.
there's actually negative fractions?
Yep, there's negative fractions and there's negative decimals. There's a negative equivalent of pretty much every number you can find. But this final fraction is equivalent to negative 2/3, and our answer is A. Does anyone have any questions on this problem?
So the answer is 2, negative 2/3.
Yep.
Okay.
All right, then let's go ahead and jump into the next problem. So problem 14, rectangle ABCD, that's referring to this big box right here, and right triangle DCE, which is this triangle right here, they have the same area. So this and this here have the same area. They are joined to form a trapezoid as shown, and we want to find the length of DE. Does anyone have ideas on how to start? Lloyd, Joyce, do you
What?
guys? Oh, well, this is the problem we are working on, and do you have any ideas on how to start on it?
Okay, what do I was talking with someone.
Oh, it's fine.
I
So
have no idea
rectangle
what to do right now.
ABCD and this triangle have the same area, and they're joined to form a trapezoid like this. And we want to
That is
find,
not a trapezoid.
well, it is because they have two parallel sides. So by definition, it's a trapezoid. And we want to find the length of side DE. Do you have any ideas how to start on this?
This is we know that side DE is probably longer than side CE.
That's a good observation.
Probably because slight line DE is like it's slanted, and line CE is not slanted. They both end at the same point, but one is slanted, which means it uses more. It's a bit longer.
Has anyone here heard of the Pythagorean theorem?
No, I know that wasn't made in Egypt.
Lloyd, Joyce, do you guys know what the Pythagorean theorem is?
I think I found
No.
it now.
I'm sorry, Joyce, what was that?
I do not know what that is.
Okay, well, the Pythagorean theorem is a very handy formula for figuring out the third side of a right triangle, given that you know the other two sides. So let's call
Well, we
sides.
don't know the other two sides.
Yeah, well, hang on real quick. I'm going to explain this real quick because we have to use this formula. So let's call side CE A, side CD B, and side DE C. So what the Pythagorean theorem says is that A squared plus B squared equals C squared. Pretty simple, right? No one has any questions about it?
Yes, I've got a lot of questions. What is A? Why is it squared? What is B? Why is it cubed?
Okay. So as I was saying, A is just like a name I'm giving the line CE. It's like just like
But
substitute.
like, why is one squared and one is cubed?
No, these are all squares. Two.
Oh.
Yeah. And B and C are also just letters, names for these two sides.
So
And
this is basically 1 plus 2 equals 3.
kind of, but the Pythagorean theorem says that a squared plus b squared equals c squared. So
Which means
basically,
1 squared plus 2 squared equals 3 squared.
well, not quite, because there doesn't exist a triangle with sides 1, 2, and 3. It's impossible. But anyways, this is the formula that we're going to use, because if we can find side A and side B, then we can find side C. Does everyone understand that? Any questions on that thought process?
Well, we could make it 1, 2, and 3. Imagine B is 1, A is 2, and then C is 3.
Well, 1 plus 2 squared is 5, and 3 squared is 9, so that doesn't quite match the formula, does it? Yeah, and so now that we know this formula that we can use, we just have to find B and A. And we actually already know B. Do you know what it is? We actually already know the number.
It's 5.
Yep. B is equal to 5. It's pretty obvious.
Oh, I get it. I get it now. So B to C is also 6. That means A is more than 6. Probably.
Yes.
Well, that's
Yes.
useless.
But now we'll find out what A is actually. So now we have to use this clue right here that they have the same area. So what's the area of ABCD?
30.
Very good. And what's the area of DCE?
DC, and D, C, and E.
30.
Very good. They have the same area. So the area of this triangle is also 30. And we want to somehow use that information to find A. So,
That means just 30 minus 5.
well, not quite, because we want to set up an equation here involving A so that we can solve for A and find out what it is. Does anyone know how to find the area of a triangle given its base and its height?
No, I did not learn about the polynomial effect.
Well, here, Kemi, since you know the formula for the square and the rectangle, how about I show you this?
Oh yeah, it's just half a rectangle.
Yep, so what's the area? One side is A, one side is 5. All right, Kemi, let's say that we want to find the area of this whole rectangle. What would the area be?
Probably double.
Well, let's temporarily.
60.
Well, yes, but we don't want the actual number right now. We want to find it in terms of A and 5.
Then that number has to be 6. There's no other way to get 60, 30.
Well, Kemi, here, how did you find the area of 30 here?
5 and 6.
5 times 6, right?
Yeah.
Length times width. So if you apply that same logic here, what is length times width here?
60.
It's 5 times A.
Okay.
Uh-huh. And since we only want the triangle here and actually not the whole rectangle, it would be 5 times A divided by what?
Wait. I think I know what A is.
Yeah, it's the name for the side. It's like the variable, if you could call that. So basically we found that the area
Wait, never mind. I forgot. I thought it was like if that, like, what if A was like 2 or something, and then C is like 3?
Kimmy, just follow along and you'll see. It's actually very surprising how easily you can solve this. So as we were saying, it's 5 times A for the whole rectangle, right? And since we only want the half of it, the triangle, it's divided by 2, isn't it? So what is the value of A? We have an equation right here.
15.
Are you sure?
I don't know, because 30 divided by 2 equals 15.
Well,
Oh, wait. Oh, never mind.
this
Oh,
2
wait,
right
A
here,
is 7.
well, if A is 7, then 7 times 5 is 35, and divided by 2, that's 17.5, which is not 30.
Wait a minute.
Well, you can think about it like this. Since
Then,
5A divided by 2, it's 30, then that means 5A is
oh,
60.
A is 12.
Very good. Exactly. A is 12.
So that means C is 13.
Very good. Well, if anyone doesn't see Kimmy's logic right there, you put 5 and 12 into the Pythagorean theorem. So 5 squared plus 12 squared equals C squared. The left side here turns out to be 169, which is equal to 13 squared, which means that C is 13. Does that make sense to everyone? Any
It makes a
questions?
lot of sense.
Great. That's good to hear. Lloyd, Joyce, do you guys have any questions?
The only thing that kind of stumps you is just the A, how to get the A.
All right, great. So that's the second problem down. We'll go on to the third. So this is another geometry problem, and it's about perimeters. And in case anyone doesn't know the perimeter of a figure,
Wait. This is a 3D shape.
it's actually 2D because it's
This
on my
looks like a
computer screen.
3D shape.
Oh, well, I can see that it's like a folded paper.
Yeah, it
Just
looks like a 3D shape.
yeah, but in this case, we're only thinking about it as like a 2D figure. So let me read the
Okay.
problem real quick. Triangles ABC, ADE, and EFG are all equilateral. Does anyone not know what that means? Equilateral?
No.
You know what
That
that means?
means that's pretty easy. That means we just need to find one side of each triangle, and then we'll find every
Kind of. So
triangle's perimeter.
yeah, so equilateral means that every side of the triangle is the same. And points D and G are midpoints of AC and AE. And a midpoint is basically the point that divides the line in half. Does that make sense to everyone? Pretty
Oh,
intuitive,
okay.
right?
I get it.
Yeah. And if AB equals 4, let me just write that real quick. What is the perimeter of this whole figure right here?
So first off, we know that 4 times 3 is 12. That means the first big triangle is 12.
All right.
And then I have no clue.
Well, Kimmy, the way you start off could work,
Oh
but
wait, you said D and G was the half point, right?
D and G are midpoints. Yep.
Yeah. So that means half of the shape is on the right side and half the shape is on the left side.
Kind of. Yeah. So this triangle right here is like on
So
exactly
couldn't
half
we
of this.
just double it? 24.
Not really, because this is a
Oh
different.
yeah.
Yeah.
Okay, I have no clue.
Well, let's start off with the fact that it's equilateral, shall we?
Okay.
So if it's equilateral and AB is 4, what is BC,
BC is 4.
right? And we also know that AC is 4, right?
Yeah.
And since D is a midpoint, can anyone tell me what is CD?
Oh, CD is 2.
Very good.
I understand what a midpoint is now. I
So
had
what?
no idea what a midpoint was.
So that means AD is also 2, right?
Yeah.
So if AD is 2 and this triangle is equilateral, what is DE?
DE is also 2.
Yep. And if G is a midpoint, what is AG?
1.
And what is GF?
1. That means 1. The smallest triangle is 1. The second big triangle is 3. I mean, the second big triangle is 6. The third big triangle is 12. So it's 12 plus 6 plus 1.
So what is the answer?
19.
19 isn't one of the choices here though.
18.
Well, we'll see. So
Oh,
now we just have to
what
let's
kind
just
of
go through this, Kimmy,
perimeter?
shall we?
That was
So
why.
we just have to add up all the sides now. So it's 4 plus 4 plus what, Kimmy?
4 plus 4 plus 4. I mean, plus, yeah, plus 4.
2 4s, right?
Yeah. No, plus 2 twos.
Well, yes, technically these two.
Like
Yeah.
plus 1 4.
So we have a side here that's 4 and a side here that's 4. A side here that's 2 and a side here that's 2. So that's 2 plus 2. Continue.
Plus 2.
Well, you want to keep in mind that this side doesn't count as a side here because it's in the inside,
Oh, yeah, and then plus 2 no, plus 1,
right?
plus 1,
Mm-hmm.
plus 1.
And
That's
what
all.
is, so that's 8, 10, 12, 13, 14, 15. So
Yeah,
the answer,
15.
ladies and gentlemen, is C. Does anyone have any questions? Lloyd, Joyce?
I see.
Good. Lloyd and Joyce, do you guys have any questions? Well, oh wait, let me check the chat real quick.
Yeah. Loy's audio isn't working. So Loy is typing in the chat.
All right, I see the chat, guys. All right, no questions. That's good. So we'll move on to the next problem. All right, this one is a little bit tricky. So the area of the rectangle ABCD is 72. And point A and the midpoints of BC and CD are joined to form a
Whoa.
triangle.
Whoa. A, B, C, D is what?
72. The area is 72.
Uh-huh.
And if point A and the midpoints of BC and CD right here, these 2 points,
Mm-hmm.
again, these are midpoints, which means they divide the line in half. They're joined to form a triangle right here, as you can see. And our goal is to find the value of this question mark, which is the area of this triangle.
I could see the first step. It's probably 72 divided by 4. Cause like we gotta find each side.
That's a good guess, Kimmy, but
And then
keep in mind that
we
72
divide it
is
by
the
2.
72 is the area, not the perimeter.
Oh, I forgot. Well, we could just try what times what times what times what that are all even equals 72.
Loy and Joyce, do you guys have any ideas on how to solve this?
Joyce said 72 divided by 2.
Well, I can see why you would say that. However, we don't know
Wait,
that
it's no.
the triangles are equal, or we don't honestly know anything about these triangles. So
He's saying eh. have no clue what to do right now.
Well,
What I would guess is like find the answer of each angle, and then we divide the angle by 2 because there's midpoints. Then we find out what like just find out how long it is. Like
well,
since the
how about
midpoints.
we do this? Since we know the area of the whole rectangle, why don't we find the areas of these 3 right triangles and subtract it from 72?
We could do that.
Yep. So now we have to find the area of these 3 right triangles. And how I want you guys to think about it is like this. Check this out. So let's say that I draw a line down the middle right here. And say that I draw another line right here. Does this give you any idea for the area of this triangle that I'm shading in?
Oh, I get it. That triangle. I don't get it.
Joyce, you're close. It's 72 divided by something, but it's not 2 because there's 4 triangles right here.
72 divided by 4.
Great. Exactly. Because you can see that this triangle is actually 1/4 of this rectangle. So the area of this is just 72 divided by 4, which is 18.
That means we know that there's 2 18s, which makes it 36.
Right?
That
And
means we can
exactly by
subtract
similar
36.
logic, this is also 18.
Yeah.
So we just have to find this.
Well, that's hard.
Well, Kimmy, we actually use the same exact idea.
Oh, dude, that's 1/6.
It's not 1/6, but you're very close.
Uh,
Joyce, it's 72 divided by something. What is it?
72 divided by 6.
No, Kimmy, not
Divided
6.
Divided by 8.
Good. Yep. Well, Joyce, see, we want to find the area of this little triangle right here.
And then
And
that's half of a square. That means we
yeah,
double it
and
on
we
each
can
square.
divide this rectangle into 4 small rectangles, and this triangle is exactly half of a rectangle. So if we have 4 rectangles and each rectangle has 2 of these triangles, so that means one triangle is 1/8 of the rectangle. Does that make sense?
That means 18 plus 18 plus
72 divided by 8, which is 9.
9. So that means
Good.
9. 18 plus 18 is 36. I know that.
And
That
plus
means
9,
45.
that's, yep. So the answer is 72 minus 45, which is
40, 27,
good.
36.
Nope, the answer is 27,
Yeah,
and the answer
I
is
messed up.
B.
I messed up on the regrouping.
It's okay, you're good. That's very good. Does everyone understand it? Any questions? I guess that makes sense. That's good. That's good. All right, the next one is a little bit challenging, but given that you guys already solved the last word, I have confidence in you guys. So consider these 2 geoboard quadrilaterals, which is these little shapes you connect by connecting the dots here. And we want to find out which of the following statements is true. A, the area of quadrilateral 1 is more than the area of quadrilateral 2. B, the area of quadrilateral 1 is less than this area. C, the quadrilaterals have the same area and the same perimeter. D, they have the same area, but the perimeter of the first one is more than the second one. And finally, the quadrilaterals have the same area, but the perimeter of 1 is less than the perimeter of 2. Well, we can't really know if any of these statements are true unless we know their areas and perimeters, right? So why don't we just go ahead and find the areas and perimeters?
Oh wait, we can. We
How?
can look this side right here, the tiny side.
Uh-huh.
It's about the size of this line. That means we know that one side is completely equal. But
Yeah,
then
but we
like
still
we
have
would
to figure out
say
the other side.
this is the same, almost the same length as this, but I think it's a bit longer.
No, it's the same. You're right. It's the same.
Yeah, and then this one we can leave as a question mark, but this one is definitely longer. This one is this a little longer than the size of this. That means this area is definitely bigger than that area.
Well, Kimmy, your idea actually works very well for the perimeter. We don't have to figure it out, but for the area, we do have to do
Yeah,
a little bit of calculations. But since Kimmy, you have the idea, let's just get rid of the perimeter first.
it's
So
a
as you
rough
said,
estimate.
yeah. So as you said, this side and this side are exactly the same. So we can just ignore these. And this side and this side are also the same. So we can ignore these as well. This side and this side are also the same, which leaves this side and this side. And it's
A very
pretty
little one
obvious.
compared to a extremely huge one.
Yeah, it's pretty obvious that the second one is a lot bigger. So that means number two has a bigger perimeter. And by that statement, we can already conclude that the answer is E. But just for the sake of doing math, let's just figure out their areas anyways.
Because this is kind of like rough estimate. It might not even be right.
Well,
It's just a rough
it
estimate.
actually is because we're not really estimating anything. We're just comparing them. And since we know for a fact that these two sides are the same, it's like it's
Oh
actually a
yeah,
very valid way of solving this problem.
yeah, true.
Yep.
And even if we only have like one side, if we don't actually measure all of the sides, we just measure these two sides, we could see that this side is bigger than that. This side is smaller than that. This side is like these two sides we can leave as mystery, but we know that they aren't that much different.
That's a great observation, Kimmy. Now let's move on to the areas. And we actually can solve this in a very easy way because consider this. Let's say we move this bottom triangle
This is
up to
this is
here.
this is just a little square.
Yep.
Somebody just pushed half of it down.
Yeah. So what's the area?
It's
It's 1, right?
true.
Yep. So the area of this is 1. And what's the area of this?
It's a little more than one.
Well,
No,
actually,
it is one.
Yep, it is exactly 1. Because you see this little triangle down here, the one I divided, that's half of a square, which means it's 1/2. And as for this one, the area of a triangle is the base times the height over 2. Does anyone know that formula, or is it like completely new to you guys?
It's kind of it's a tiny bit new. I've heard of it a lot, and I've tried some triangles with it. But
Yeah, we actually just
I've never actually used that in like an actual math problem because
yeah, we
none of them
actually went
actually
over that
required
the
that.
second problem that we did, remember?
Oh
So
yeah.
yeah, so pretend that we add on this other half of this. So the area of this whole rectangle is base times height, right?
Uh-huh.
Yeah. And if we take away this other side, we have one side left. So that's divided by 2, which is this. So the area of a triangle with base B and height H is base times height over 2. Does that make sense?
Yeah.
Great. So in this case, we can see the base is 1, right? Pretty clear.
Yeah. And
And
then
the height is
it's
also 1.
probably 1. Yeah.
So 1 times 1 over 2 is just 1/2.
Yeah, that means 1/2 plus 1/2 is 1. That means it's also 1.
Exactly. So they have the same area, which means
But
the
not the same
answer is B.
perimeter.
Pretty cool problem. Do you guys have
Yeah.
any questions?
I saw something kind of tricky. Number
Uh-huh.
D, it's almost right, but it says number 1. It flipped number 1 and 2
Yep.
upside down. So I would say that's kind of catchy. Because
Yeah,
most times people only read like the first few like words and they don't really read the last few words.
yeah, Kimmy, that's a great observation. So if you three ever take the AMC tests, one thing you have to keep in mind is to read the questions and answer choices really carefully, because you could spend 10 minutes solving a problem and get it wrong because you make a mistake, like Kimmy just described. So when you solve a problem, make sure to read. All right, if nobody has any questions, we're gonna go on to our last problem.
Last problem already?
Yep. All right, let's check this out. So triangle ABC, which is this left triangle right here, is an isosceles triangle with AB equals BC.
Okay, so probably we know that two sides are the exact same. And we could probably estimate that.
Well, Kimmy, let's finish
B.
reading the problem first, shall we?
Okay.
Yeah.
Where were you on?
All right, so if anyone doesn't know what isosceles means, it basically means that two sides are the same. And they already told us AB is equal to BC. So no questions, right? Any questions?
No questions except for there's a question. What is the area?
Joyce, are you trying to say something?
No, sorry.
You're good. And point D is the midpoint of both BC and AE. And as we already discussed, the midpoint divides the line in half, which means BD equals DC and AD equals DE. CE is 11 units long, so we'll just write that real quick, 11. Triangle ABD is congruent to triangle ECD. Does anyone know what congruent means?
The same.
Good. So triangle ABD is congruent to triangle ECD means that these two triangles are exactly the same. So they have the same side
It
lengths,
was turned.
the same angles, the same area, the same everything.
I think it was turned like 180 degrees.
Yes. So congruency doesn't necessarily mean that they're in the same orientation, but everything else about them is the same.
That means like their size.
Yes.
But their color could be different.
Their color, yes, but that's not really important for the sake of this problem, is it?
Okay, because, yeah, we don't really matter about the color because they both are white.
Yeah. And we're trying to figure out the length of BD. So why don't we go ahead and give this?
B and D?
No, the length of this line BD.
B and B?
No, BD here.
Oh, BD, that's easy.
All right, Kemi, what do you think we should do?
Probably we gotta first like find out B and C.
Yes, we need to find BC, but
Well,
how would we do that?
we know the base of E and C is 11. That
Well,
means A and B is also 11. That means B and C is also 11. That means 11 divided by 2
is
5.5.
congratulations, Kemi. You just solved the whole problem in less than 30 seconds. Well, for the other two, Boy and Joyce, basically what we're doing here is we're utilizing the fact that triangle ABD is completely equal to triangle ECD. So since these two triangles are completely equal, and we know that EC is 11, what is the length of AB? This is a question for Loy and Joyce. Good, Joyce, it's 11, very good. And since we know that triangle ABC is isosceles with AB equals BC, what is the length of BC? This is also a question for Loy and Joyce. Very good, it's again 11. Finally, we know that D is a midpoint, so what is the length of BD? Great, it's
A
5.5.
random huge 5.5 appears out of nowhere.
Yes, it is 5.5. Well, we already solved all of these problems. So we have 10 minutes left. And do you guys want to end this class earlier, or I have another interesting puzzle and we could do that for 10 minutes? What do you guys want to do?
Puzzle.
What is the puzzle? What is
All right,
the puzzle?
puzzle it is.
What is the puzzle?
Let me share my screen real quick. So this
Oh
is
yeah, I want this. I want this.
domino dissection.
I love domino
And
dissection.
basically what you want to do is you have like a grid of domino parts here, and you want to fit these domino onto the grid so that it completely covers the grid. So for example, we could put these two as
Just
one
saying,
domino.
it's not in full screen.
It's not in full screen?
Yeah.
Oh, all right, is that better?
Yeah.
All right, so Lloyd, Joyce, Kimmy, does the rules of this puzzle make sense to you guys?
Yes, I played this before. It's so fun.
Good. Lloyd, Joyce, do you guys understand it?
Yes.
Good. Oh, and one thing I have forgot to mention is you can only use each domino piece once. So you can't
Yeah,
use,
and you can't go diagonal.
yep. All right, so go ahead. Which piece should I use? You guys tell me.
I'll annotate the pieces. These two, I would say.
Which two? Oh, this, okay.
These two.
Okay.
These.
Well,
Well,
Kimmy,
no,
if you
actually, these two. These two.
good.
Yeah, and then these two,
Uh-huh.
and then these two. I played this along.
Good. All right, Loy and Joyce, do you guys want to try this next puzzle?
Every time you do
Yes.
something right, it just gives you something
All right, Joyce, go ahead.
so lame. Like, just you win.
Joyce, you can
Um.
just annotate like Kimmy just did, or you can just like say it to me. Your
Okay.
choice.
So these two,
Uh-huh.
and then does it have to be upright?
No.
No, you can
Okay.
make it horizontal or, yep, okay.
And then
Oh. I think he's off to a very good start.
Uh-huh.
and
Uh-huh.
then this, and then this.
Good. Very
Yes.
good. Congratulations.
A
Lloyd,
very
do you want to try
lame
this
you
next one?
win. A very lame you win.
Hey, Lloyd, do you want to try the puzzle? Well, since we already did the easy one, we're gonna just skip a couple levels and go to
Go
like
to level
level.
10.
All right,
We're going to
level 10
level
it
10.
is. All right, go ahead.
Yes.
I'll try.
Okay.
I'll try.
Okay.
I got it. These two.
Uh-huh.
These two.
Okay.
These two.
Good.
these two.
Good.
Oh wait, redo that, please. Undo that.
Undo.
Yep. These two,
Okay.
these two, and those two. I'm
All
trying
right.
to like keep it. I'm trying to go like side by side, and I'm trying to keep it like in a clump. That way, I don't like suddenly use so much, and then there's just a bunch of random pieces.
Good. Yeah, that's good. Well, guys, there's actually like a little trick that you can use to eliminate some pieces, and that is to put the pieces with both sides the same first. So you would put this piece, you would put this piece, and this piece first, because it's kind of obvious where they go, you know?
Like,
So Joyce, do you want to use that trick and
wait, do
solve
you
this one?
mean these two, these two, these two,
Yes.
these two?
Yeah, that's what I meant, because usually these are pretty obvious where they go compared to like these other ones you have a lot of choices. So you want to start with these ones and it's easier.
He just gave out the
I
answer.
found the
Can you
answers.
move up a level?
Oh yeah, sure. All right, Kemi, stop annotating. Don't give out the answer.
Stop it.
All right, go ahead, Joyce.
Oh god, this looks hard.
Okay. Okay. You could just mark, yeah, that's what I meant.
Undo that.
Yes, ma'am. Continue.
Okay. Wait. Wait a minute.
I think he did something wrong. I actually think you did something wrong.
I also
wait,
think
you
I
did
did
not.
something wrong.
Yeah,
Now
I
No,
think you did something
wait.
I
wrong.
think you
You're
might
kind
want
of
to
like
put
stuck.
these two together.
I
Wait.
think you're stuck.
I'm
I think you're
confused.
stuck. Like if these two go together
Restart
and
it.
these two, like
Okay.
these four don't do anything.
Okay. Let's just do this. And then do this.
Yep.
And
And
then
then the other
do this.
obvious choice.
And
no,
then wait.
no, the
No.
other
Never
obvious
mind. Never
choice.
mind. Redo it.
All right.
I'm sorry. I'm bad at this.
No, it's okay. You're doing good.
Here.
The two obvious ones.
Here. And then here. And then here.
Good.
Yay.
All right. You guys want to try level 40? I think that's like the last level for.
Yes,
Okay.
yes.
Yes. Can I try?
Yeah, sure. Go ahead.
Something's on
Oops.
the board. Okay. Boom. Okay, first thing wrong.
Wait.
Undo.
Got the very first thing wrong.
Wait.
This.
Yeah,
This is
Joyce?
this is a little confusing.
It's
Yeah,
these two.
because there's a lot of different choices you could make, so we got to do like a bit of trial and error and
Can
test
I
it
make
out.
this one?
Okay.
Okay. This one. I'm going with my clump.
Wait, I don't think that. Wait,
These two.
that is right. That is right. I think. Wait,
Okay.
no.
Yep.
Yes, no, yes. I think so.
Yeah.
Hmm.
No.
No.
That's not possible. That's not.
Yeah, we're a little stuck here.
Oh, I got it. Could we undo all the way? And I want these two.
All right. Oh no.
And then these two.
Actually, Kimmy, you see, if you do these, then these two are kind of like stuck here.
True.
So we know that these
Oh.
cannot be the same puzzle.
These two. I got it. And then these two. These two. I'm slowly building up. These two.
Ooh, we did it. Yeah.
Good.
Yeah.
A tiny bit
All right,
harder.
do you guys want to try like one of these harder ones, like 5 by
Do
4,
it.
6 by
Do
5?
it. Do it. 8 by 7.
All
Yes.
right.
Do level 200 8 by 7.
No. That's too hard.
199.
All right, Joyce,
Let's
which
just see
number?
what 199 is.
190.
All right, 190 it is.
Oh my god.
Oh god.
This is gonna take a while.
Oh god. Wait, over here. And then uh
How many are there? It's gonna be so. It's
Well,
gonna
we
here,
be
know these
so
two has to
long
go
to
together, don't we?
do
Yeah.
155.
there, maybe.
Maybe.
I think.
It's all
Okay.
just shattered across the world.
Here
Perhaps.
and then
Well, we know these two has to go together.
I would
yes.
say these two. I would say these two.
We'll see.
Wait. That one might be wrong.
Which
No,
one?
but like
The blue.
Oh, yeah, it could be because there's a lot of different options.
Yes.
I would say the blue is actually correct, because then we could do this, and we could fill in the blue that'll do, this'll do, that.
What?
Bing, bang, boom.
Well, let me just follow Kemi's markings real quick, shall?
And here,
Oh,
wait.
Kemi, it appears to be working.
It was literal random.
Oh no.
Oh.
Okay, delete that.
Oh
delete that.
no.
I figured it out. Okay, we were going so well. I've defeated like so many.
Oh
We're gonna have to
no.
do this.
90 perhaps.
These two? Okay.
Yes. And then
These. Okay, I'm gonna go back to my spamming ability. This,
what?
that, this, don't, thing.
I can't even tell where you're doing it.
It's just
It's messy.
random.
Oh no,
Okay,
Kemi.
delete
This is
that.
not gonna work.
We're just going completely random.
Oh
Okay,
no.
delete that. Oh, I know. No, delete that. It's these two.
No, it's not
delete
gonna
that.
work.
Yeah. It's
No, we messed up sure.
No,
So
we
we're
only
gonna
have
have
like
to
a
restart
few
the whole
left.
thing. I
That
know,
won't
but
really work.
Oh wait.
oh wait, we can restart
Wait.
this.
Wait, is that right?
Yeah, that works.
And then here.
Oh.
Oh
Wait,
no.
never mind.
Oh no.
Okay, and then yeah.
I don't think there's
Wait.
a 3 and 5.
Wait.
Yeah, we did 3 and 5. Guys, I think we should have done a 3 and 5 and then a 2 and 6.
Mm.
Oh well, we have a 2 and 6.
Or those. Or
Yeah,
I
we
don't
should have
know.
done that. And a 1 and 1, and then 3 and 1 and 3.
Wait,
And
that's
No.
not possible.
no, change that. 3 and 6. No, 1 and 6.
I think we're
We're
Oh
stuck.
my god. 4.
We're
There
stuck.
was 2
no, we're
left.
so close.
We
No.
have to be diagonal. We were so close. The spamming did so well.
Wait a minute. Go back.
All right. We're gonna have to end this soon though.
No. Bye bye.
Well, wait, don't go yet. If you guys want to do this, like while you're waiting, I can send you guys the link, and you
Yes,
can do
please.
it when you're bored.
Yes, please.
Anyway, bye.
And try to figure out puzzle 190 next classes, and if anyone has the solution, we can present it to everyone.
I'm doing 199.
Okay.
All right, sounds good.
So I can finish.
Good job,
Bye.
everyone. Bye.
Bye.
Bye, Loy. Good job.